I'm Benny, and with me today I have Patrick. So together today we're going to cover the best practices for GIS layers and server and services at a conceptual level on the different service types. So Patrick will be demoing how to configure and tune the different GIS services. So talking about concepts, here is a high-level context from ArcGIS platform perspective. It's about connecting your users with data in a meaningful way to help them do what they want to do. So this stack, what you have seen here is four main components. At the bottom level, what we have is the different storage types. For example, your file databases, your blob stores, and on the next is a functionality that turns your data into a function. For example, your 3D and your streaming imagery. And taking those data and functionality, making it into something meaningful and reusable is an information model whereby you can then provide something that makes sense to your users. And on top of that, encapsulating everything is a user experience, connecting the information product to the user via something like an web application. So how does all this then maps to your various components of ArcGIS Enterprise? So at the storage level, we have the ArcGIS managed data stores, and the functionality is being provided by your ArcGIS servers. So the information model is then provided by the portal for ArcGIS Enterprise to give you something like, for example, your web maps and your web layers. And finally, connecting the web maps and your web layers to the users are your web applications. So from an information perspective, in terms of what we publish to ArcGIS, there's data, there's services like your REST-based web service, there's your web maps and layers, and on top of that are the applications. So what we will be focusing today is actually the two middle piece of the sandwich. So it's to understand how to connect the two ends of the spectrum and how these various things can be published and how you can leverage them to really deliver the right data, functionality, and experience to the right users. So it's always about the technical decisions meeting your business requirements. So it's always important to remember the business goals and objectives that you want to achieve at the end. So your publication strategy, the layers and the service types that you're going to publish will be quite different based on use case to use case. So example, are you trying to support a public utility organization to set up a power outage app? So what you need are extremely highly available services that can support large volumes of users, for example. So now let's look at the different service types that ArcGIS can support. So the four most commonly ones that ArcGIS Enterprise can support for 2D mapping are as shown here. So there's another set of services that still fall within the mapping and visualization category, including image services, with focusing on your imagery, raster data types, and your elevation data, and the scene services which focus on your 3D visualization, and not forgetting your stream services provided by ArcGIS Geo Event Server that gives you the real-time pushing of features to clients over things like your WebSockets. So there's also other services that goes beyond just visualization, for example, geocoding, and the different types of analysis services, as well as the more specialized and even domain-specific ones, for example, workflow manager and your maritime services. So without further ado, let's look at these concepts in practice. So we have the geo information model, which is the higher level of abstraction on top of the many different service types and data types that we support within ArcGIS. So we refer data at this higher level as web layers used within web maps. So let's think of these web layers, web maps, and web scenes as essentially your configuration files for all of your web applications. So how does all these then maps to our conceptual model from the beginning? We might have a single data set, and then depending on how you look at the data set, previously it was very common to publish out multiple services. So one service might have all the data with no filter, and that was very tightly controlled with some sort of security mechanism in the past, because only a few people should see all of the data. And if you want another view of the same data, Maybe you will need to publish a separate service with a filter on the results and publish many different views on top of the same data. And this is very powerful, right? Because you get different views for different people for different applications. And in the portal, this will all become your individual web layers, and each one of the services has a corresponding layers, and then you can then create additional layer with different properties on top. But wait, the downside of this approach will be that you have a lot of services, and services can get expensive in terms of memory footprint because each service is backed by a service instance and memory on the server. And this is something often that get tightly controlled from a financial perspective. So what the geo information model and these newer capabilities within ArcGIS allow us to do in many cases is to collapse them down. So instead of having to publish out separate service for every single variation, you can publish a single service and apply the filtering inside the higher level of the web layer level. So if you, for example, want to change the styling, the filtering can be done through the web layer instead. So to give you another example, in practice, we might have a wells dataset, and we can publish a single well service, and we start to add our layers on top. So one of those layers might have a certain subset of data, for example, active wells. And another of those might be showing a different set, for example, proposed wells. And we can keep on going and going. So making smart use of the layers at the portal level can really improve your back-end infrastructure. But the more important things is you need to think things through and ask questions like, for example, where does my data resides? Who's publishing them and how they're publishing it. So all this requires the user involved in the whole workflow to work together and plan this ahead of time. So now I want to show you one particular use case, which is a success story from a UK electric utility company and how they use ArcGIS Enterprise to cut their workforce requirements down by 50%. So they have few workers out going out in the field to collect utility data. So apart from the challenges you've seen on the slides, they also need street as a base map, and they are visualizing and collecting complex data out in the field, and in some cases without internet connectivity. So the application service type used in this success story applied the vector tile services for the base maps. Because vector tile services are smaller, they can be taken offline in the field. So vector tile package for street maps can be pre-cooked for the entire service area, preload onto the device, and have users download them from time to time. So the operational data of the utilities require you to edit and be taken offline. So feature services are really the best option here. So this is going to be a mobile offline option. So having device to work with a local tile cache as well as a local runtime database, which house the features can be useful too. So remembering this is an offline use case, so you will need periodically syncs to carry out, and we have the feature service sync capability to do that. So this is another example of how you can put things through together for a specific use case. So next, let's have Patrick in action on tuning and configuring the enterprise GIS services. Patrick, please.
Okay, thank you, Benny. Okay, so right now I'll be showing some tuning to the services for better performance. As you might have known, it's very easy to publish service right away as ArcGIS Desktop sets many of the default service properties for you. But what if there's going to be hundreds or even thousands of users accessing your data? Then what should you do? It will be best to change some of the default services property to suit your deployment. Okay, so in Singapore, it's very common for medium-income family to have both parents working. So this will result in them having to put their children in childcare center. So location definitely plays a big part in their selection. Okay, so what I have here is an all-in-one map service for parents to search and discover childcare center that meet their needs. Then this map service, right, comprises of childcare, elder care, AED, HDB car parks, and boundary layers which service the public inquiries. So all the data that I'm using are downloaded from data.gov.sg. Okay, so all-in-one map service actually consumes a lot of resources, especially when there are quite a number of layers in the service, and when not all of them are being used at all times. So now let us go to the server manager and take a look at the public service map sheet to see what we can fine-tune. Okay, so this is the ArcGIS server manager. Okay, so on the side tab here, shows a number of options which you can fine-tune for the parameters. Okay, so we'll first go into the parameter subtab. Okay, so in the parameter option, under anti-aliasing, you can adjust the settings for it. Okay, so pick whichever type that best fit your needs for the map service that you want to present to your audience. But if anti-aliasing is not needed for improving the map performance or display, then use none. And usually we'll leave it to the default of none, since it will provide the best performance. Okay, so for us, right now for me, we'll leave it to the default of none and normal for anti-aliasing and text anti-aliasing, since I do not need smooth graphic details. Okay, then next for max number of records written by server. Specifying a large number of records to be written by server can slow the performance of the web browser or your server. If you know that a particular service will not be accessed by a huge pool of users, you can give it a very low number to it. So in my instance, for example, if I'm looking for a childcare center within my area, do I need a service to return me 1,000 records, or do I need 10? Okay, so for us, let's take 10. And next, we'll look at the capability subtab. Okay, the capability subtab allows you to configure the capabilities that you want to enable for your map service. If your map service is for pure visualization, you should disable any of these capabilities to prevent user from activating it, such as querying the data source or editing. Especially for editing, the browser will make larger requests on the full geometry of the layer, which makes the layer slow to draw. Okay, next we will take a look at the pooling subtab. Okay, the number of instances running to complete requests can cause the ArcGIS server performance issue as it consumes high memory resources. So consider setting the minimum number of instances to 0 for those rarely used services or when the sharing of instance pool functionality is not an option, as this will reserve memory and space capacity for other more heavily used services, such as active map and geoprocessing services. But the downside to this is that there will be delayed performance, as it will take times for the instance to spin up after a request. So for services that are highly consumed by user, set it to 1 or 2 for the minimum level, and leave the default of 2 for maximum. If needed to increase, the general rule of thumb is the maximum number of instances to never exceed the number of core on your ArcGIS server machine plus 1. Okay, which is, if you have a 4-core server machine, the max number of instances per machine should never exceed 5. Okay, so for me, let's set it to 0 and 1. As for the service timeout, setting the correct maximum usage time prevents the client from holding reference to the services for too long before releasing it. For example, a service with only one layer that is used to draw map in the application might only have a maximum usage time of 1 minute, as compared to a service that is used to perform geodatabase checkouts, which might use 10 minutes. Okay, so let's set to 10 minutes for the maximum time a client can use the service. And 2 minutes for the maximum the client can use the service, and same for the maximum time and either instance can be kept running. Okay, last but not least, recycling service, which can be found in the process tab. Recycling will destroy unusable service and replace them with fresh new service. It will also reclaim resources taken up by the stale services. Recycling actually allows you to keep your pool of service fresh so as to maintain steady performance. Okay, so by tuning what I've mentioned before, the after effect is a reduction of unnecessary resource usage by either services. You will get better and faster performance with more resource available. So, like example, in situation where computing resources like RAM is limited. Okay, so it's a good idea to take a close look at the way that your service has been authored before publishing. Okay, but before I end off, a few pro tips on pre-publishing consideration. First, remove unnecessary layers and remove or hide unnecessary fields. Okay, we always want to provide as much information as possible to the user, but are they really required? So, like for fields, lesser field in the inquiries will shorten the search and also uses less resources. Secondly, make smart symbology decision. Simplify symbology for those non-cache services. As halos and offset, they are a great contributor to poor drawing performance. Use EMF file type for picture symbols if the marker is of a single color, and PNG for multicolor picture symbol with built-in halo background. Okay, and lastly, set scale dependency rendering for your layers when you publish so that they do not draw at all scale ranges. Okay, with that, I conclude my demonstration and hand over back to Benny. Thank you.
Thank you, Patrick. So before we close, let me give you a sneak preview on a new tool in Enterprise GIS called ArcGIS Milito. So like doctor uses tools to monitor the patient's health, diagnose a problem, and determine how to treat their illnesses, you can now use ArcGIS Milito to do the same thing on your ArcGIS implementation. So ArcGIS Milito is a tool uniquely tailored and designed to monitor the health of your ArcGIS implementation throughout the whole life cycle, giving you the awareness of the system usage and performance, helping you to get the most out of your GIS and IT investments. They always say that prevention is better than cure. So this allows you to diagnose your potential problem before they arise and help you to plan your future investments by analyzing your historical trends. So this particular diagram illustrates the system components that ArcGIS Monitor can work with. So as you can see, it is not limited to just ArcGIS product, but it extends to the whole enterprise GIS deployment. For example, the network, the relational databases, your SSL certificates, load balancers, and hardware, etc. And these are the products and data used in Patrick's demo. And these are the useful links for you to check out for more details. And finally, you can visit our website to check out the training schedule and consult us with regards to your GIS training path. And this marks the end of the presentation. Thank you very much
Thank you.
for being
Thank you,
here.
Benny and Patrick. We have a few questions that have come in.
Okay. Okay. So let me answer the first question. I'm using a previous version of the ArcGIS server. Can I use the ArcGIS Milito 10.7 with my environment? The answer is yes. ArcGIS Milito can help you to monitor the ArcGIS server from version 10.2 and above. Okay. Second question. Can I install ArcGIS Milito on the same machine where I have my ArcGIS Milito 10.6 running? This particular answer is you can only have one version of that running. So what I suggest you to do is to upgrade your version from 10.6 or 10.6.1 to 10.7 instead. So do we have time for another question?
Yes, we do.
Okay, so how do I counter the drawback of setting the minimum instance to 0? Patrick, do you want to answer?
Okay, actually, to that question, you can just up the max time, the max idle time for the instance running. Okay, even though the default is 30 minutes, which is quite a lot. Yeah, so depending, you can up that time so that you can always have, you will not encounter this kind of question, this kind of problem.
I think we can take one more question.
Okay, last one. Can ArcGIS Milito be installed on a virtual machine? Okay, so this particular answer, it is yes. It is similar to you installing it on the hardware, as long as it can meet the hardware requirements of the VM as well as operating system of the host machine, then you will be able to install it as well.